me here this morning. My name's Mike Willard. I'm a software design engineer in the test group of Visual Basic, and I'm, of course, with Microsoft Corporation. Today I'm going to be going through Internet development in Visual Basic 6.0, specifically new features with web classes. The topics I'll be covering today. First, what is a web class? Then we're going to go on to what can a web class do. From there, we're going to go through the basic architecture in web classes. Then we're going to go through debugging that you get for free with web classes and the Visual Basic IDE. Then we're going to go into the actual programming model, the syntax you use to build web class applications. We're going to cover the ASP objects, since web classes are VB's way of accessing those objects. State management. State management is always important when you're building end-tier architecture systems. We're going to go through how to deal with state in your web class applications. Then we're going to go through some advanced topics such as performance, scalability, transactions. I'm going to go through a brief summary, and as time permits, I'm going to take questions. Plus, throughout the demonstration, I'm going to be going through some code to illustrate techniques to build web class applications. So to start off, I want to show you a simple web class application that I built. This is a mock flight reservation system. Okay, you get all the richness of HTML in a user interface, and I'm just going to log in here. Again, a very simple application. Okay, with this application, you get three functions. The ability to browse available flights, the ability to enter a new flight, and the ability to review the booked flights that you've entered. Now, let me see a show of hands here. How many of you have actually wrote script programming Internet applications? Okay, that's a pretty sizable amount. Okay, what I'd like you to think about is what kind of things you need to be doing right now in script to get this kind of functionality in an Internet application. Okay, to browse flights, all I'm going to be doing is I'm going to be calling into a middle tier object, which may or may not reside in MTS. Okay, and all that middle tier object is going to do is access the backend database and retrieve information and show it in an HTML table. Now, to book a flight, we just enter the data right in the UI here. Just select OK. And what's going to happen here is I'm sending the data I just entered to the middle tier component. The middle tier component is going to write the data out to the database. And here now we review these, and you see at the bottom here, my flight has been entered. Okay, again, to retrieve these flights, to retrieve the booked information, I'm again using a middle tier component from the web class to gather the information and show it as an HTML response inside the application. Okay, here. I have a little problem with the screens right now, so let's just see what's going on. Get some help here. Okay, this is just a real quick technical difficulty. We'll get through this. This wasn't VB's fault, by the way. Okay, imagine, if you will, there's a slide up here real quick. Okay. Briefly, I'm going to go through what is a web class. Okay. First and foremost, it's a COM component. Okay, it follows all the rules of a component object model. Okay. Still not working. Okay. Okay, so as I was mentioning, it's a COM component. It's built using an ActiveX designer in the Visual Basic IDE. Through that, it uses all the facilities in Visual Basic. And web classes are a great way to abstract your user interface, the HTML, from your programming code. And again, if you're familiar in programming apps, then sometimes you've noticed that the code starts looking like the HTML, vice versa. It can get really confusing sometimes. Web classes allow you to make that separation. Web classes run under Internet Information Server control. They are hosted behind an active server page. And in a few minutes, we're going to actually, wow, okay, we got that back. All right. They're actually hosted behind an active server page, and we're going to see what that page looks like in a few minutes. Also, since this is running under IIS control, you can run it in process or out of process. Okay, a web class. A web class is a container for web items. Now, let me back up for a moment and describe exactly what a web item is. A web item is a logical block that represents some form of HTTP response back to the client, or some way in which you package up your code in a web class. It's the way you navigate around in your web class. There are two types of web items. One, an HTML template web item. This type of web item has HTML associated with it. Second, you have a custom web item. This type of web item has no HTML associated with it, just Visual Basic code. Now, this may just perform functions or some kind of calculation, or it can also use the response object to write out HTML to the browser. A web class has a defined lifecycle. This is very important. You get creation and destruction events for whenever you go to enter the web class and leave. So if you need to gather state, write state, you can do it in both the creation and destruction events. For each HTTP request you make from the client to the server, you have a begin and end request event. So again, any cleanup or initialization code you need to do can be handled in these events as well. The web class has a start event. Think of the start event, if you've built programs in Visual Basic before, it's synonymous with a sub-main. Or if you're more familiar with C or C++ applications, think of it as a win main in C or C++. But there's also specific request events. Now, as I was talking before about web items can have events off of them. Okay, and you can call into these events via a URL you send from the browser to the server. We'll see in a few minutes how you actually get to these events. As I was mentioning, web classes respond to HTTP requests, basically get and post requests. The requests are mapped to events, and you have full access to the ASP programming model. Anything you can do in script, anything you can do in ASP, you can do from a web class. You can return any valid MIME type, XML, JPEG, HTML, etc. Okay, this is a structural diagram of the web class architecture. On the bottom, you'll see that we have any browser on any platform. This is one of the main strengths of web classes, that you can run this on any client platform that you wish, as long as there's browser support there. In the middle, you'll see the actual web class. The web class resides on NT server with IIS 3.0 or above. Now, the web class, in turn, since it's a COM component, can access COM objects on the server or on another server. Those COM objects may represent business rules or other functionality you want in your internet application. On the very left, you have HTML templates that can be imported into your web class application. These HTML templates are the UI that the user is going to see in your application. Plus, you can just also directly use OLEDB or ADO from web classes to access data or state. Calling events. Okay, the web class will always be calling events. And the way it does this is through decorated URLs, meaning we have defined parameters on a URL. We're expecting these parameters when we go to call into the web class. These parameters tell us what web item we want to actually execute and the event off of that web item we want to execute. Now, these parameters that I've been talking about are referred to as WCI and WCE. Normally, you'll never have to worry about these because we have helper functions which generate these URLs at any point. But WCI stands for the actual web item, WCE for the event on that web item. Now, if you're going into the start event, remember the start event is the initial entry point into the web class. You can just enter a URL without any of these parameters, and you'll automatically go to that event. I want to go briefly into the relationship between this apps page I've been talking about and a web class. Each web class you create in Visual Basic is going to have a one-to-one relationship with an apps file. When you go and type in a URL to your web class application, it's going to be a URL to an ASP page. This ASP page gets generated by Visual Basic upon compiling your web class application. Now, web class has multiple web items, and for any useful web class application, you're going to have multiple web items. Right now, I'd like to show you what this ASP file looks like. All right, I got it this time. Okay, as I mentioned, this ASP file is actually created by Visual Basic upon compile. And all we're doing here, we're setting a couple value properties for response, but the interesting part comes when we're actually checking to see if an instance of our web class runtime manager has already been loaded or not. If not, what we will do is we will go and create a new instance down here, server.createObject, webclassruntime.webclassmanager. Now, once we are sure that we have this created, what will happen is this is where we actually fire and invoke the web item and the appropriate event off of the web item. What we will do is we will call a method off of the web class runtime, either process no state web class for web classes that have state management turned on, and I'll get to state management later in the talk, or process retain state web class, which is state management turned on in the web class. So all we're doing here in the ASP file is we're sending the name of the project with the web class file. And since we're in the ASP file, we already have the parameters WCI and WCE. They're accessible through the query string. So once we send this, we're going to be able to look up what code in the compiled DLL to execute. Also, would like to go through the simplest web class application you're going to ever build. So let's just try new project from the Visual Basic IDE and select IIS application. And here you see the web class design surface. Here you have the name of the web class and folders for HTML template web items and custom web items. Again, we're going to get into what these web items stand for, but this is where you go and enter new web items. Now, when we view the code, this is very simple code. We're going to reply with a response to the user that this response was created in the start event. So I also want to show you that we have debugging capabilities right within the IDE. I don't know how many of you have tried to debug Visual Basic code before that has been running in the IIS process, but it's never been that easy to do until now, because we can actually go in and do it. So what we do is we automatically come into the web class start event. This is because we started up with the ASP file with no parameters on the URL. And we execute the code. And we end up with WebClass's one starting page and the response. Okay, as you saw, I was actually debugging through that code. The other points I want to mention about debugging is we support automatically building a virtual root for you when you go to create a new project. So we'll ask you to make sure that the name is satisfactory with you, and if it's not, you can also type in a new name for the virtual root in IIS. We automatically launch Internet Explorer 4 and navigate to the page in which you need to go through. One caveat is we have out-of-process execution under the IDE, but you can only do this on the local machine. You can't do remote machine debugging yet. Good points about this are that you have edit and continue capabilities, you can set breakpoints, you have code sense, and since this is a COM component again, you can step into other COM components. The programming model. Okay. What we saw before was a simple WebClass application. It didn't even have any web items. We just sent a standard response out from the start. So for a WebClass application to be useful, we're going to need multiple web items in the application. Think of each web item as representing a page or a response to the user. And as I mentioned before, each web item can have events. Form post retrieval, image retrieval, etc. How we move between those web items is done through the next item property of the web class itself. And to show this, I'm going to go into another demo. Okay, basically, what this demonstration is going to do, I have a few web items here. I have an HTML template web item, and I have two custom web items. The application is going to start off showing this HTML template web item. The HTML is going to have two buttons. Now, for each button I choose, I'm going to automatically invoke code in another web item, which are these custom web items down here, first response and second response. So let's actually start stepping through the code here again. Okay, we go into WebClass start again. And here we set next item equal to choice page. Choice page is the name of our HTML template web item. Now in turn, what this does is automatically invokes the default event of this web item. The default event of any web item, as I'll go into more later, is always respond. And here all I'm doing is choosing to write the template out. It'll just send the HTML out to the client. As you see here, I have a simple page with two buttons on it, response 1 and response 2. Now when I click on response 1, I go back into Visual Basic Code again. I'm actually intersecting that. And I go in here and I use the request object, the ASP request object, to determine which button was actually clicked. I see that response 1 was clicked, so I say let's set the next item equal to our custom web item, first response. And I'll automatically fall into the first response respond event, the default event again. And all I'm doing here is writing out a simple message to the user. You chose response 1. Now, just to make sure I'm being honest here, I'll go back and choose response 2. As you see, we're just setting the next item to wherever we need to go in code. Okay, Now that I've talked about how to move between web items, it's time to start talking about just what these web items are and really get in depth. A custom web item, a web item without HTML. That's the only thing you really need to remember about this. No predefined associated HTML with them. However, it can represent generated content. You can use the response object to write HTML out to the client. Or it can just represent functionality in which you read a database, calculate some information that you need. It's also connectable from other web items. So for example, those buttons that I had on the HTML page on our previous example, I could connect those buttons directly to a custom web item if I needed to. You can also generate a reference at runtime using the URL for helper method. And basically what this does is it generates the URL needed to actually access the code for that web item. So for example, if I had a web item called X, okay, and an event off of it called Y, and the project's name was project 1, it would give me project1.asp question mark WCI for the web item equals X, and WCE equals Y for the event. So let's again go into some more code. Okay, in this example, I have a custom web item called web item 1 with an event that I defined off of it. Now, you define events off of your custom web items just by simply right-clicking on the web item itself and add custom event, and you get a new event that you can actually call into. Now, let's view the code I actually have written behind this example. In the start event, I'm actually going to web item 1. Then again, the default event that gets fired is the respond event. So let's just start stepping into this code, actually. So now in the respond event, all I'm doing is I'm giving the user a message. Click below to execute the event off the web item. And I've wrote a little helper function, HTML hyperlink, to gather some data and write it out to the web page. Now what this is doing is, basically, I mentioned URL before and how it gives you the basic URL to access a web item and any event off of that web item. Well, still you need to do a little bit more around it to actually write it to a web page and have a user be able to click on it. So all I'm doing here is putting the anchor tag around it and giving it a name that makes sense on the page itself. And as you see here, here's the WebClass URL for function. You add a watch on destination. Destination is just the web item that I want to generate a URL for, and the event name is just the event name I need to generate it for. So as we continue stepping through this code, we get this response. Now we have a URL that's clickable from this web page. We'll click that, and we're actually invoking now the event 1 event off of web item 1. We'll step through this code, and now what I'm going to do is call this helper function again on an event that I have not defined at design time. What this is going to do, this is going to generate a user event, and you can catch user events in your code. So let's just step through this. And real quick, let's look at the URL we have. Well, that's not very seeable from the screen here, but basically what we have on here is the ASP page with the appropriate parameters to call into the web item and the event on that web item. Now let's actually click on this new hyperlink to execute a user-defined event. Again, this event wasn't defined at design time. So I'll automatically fall into an event called user event off of web item 1, which is our custom web item. Now, this one was hard-coded in here, but imagine, if you will, you could also look up event names or gather them from a database. You can dynamically generate events, or may have events that get generated on the fly that you could catch in the user event code here. So for simplicity's sake, I just hard-coded no event in here. And all I'm doing here is giving a response out to the client. You execute a user event called no event off of web item 1. Okay. As I mentioned before, respond, that is the default event that gets called if you don't provide an event name that you want to call on a web item. The user event is an event that's not generated at design time, it's generated at runtime. Custom events, on the other hand, are generated at design time. And process tag is something that's going to be interesting when we look at HTML template web items. These aren't used in custom web items, so let's just move on to HTML templates. Okay, the important thing to remember about an HTML template web item is that you're associating predefined HTML pages with the web item. You can expose tags on that HTML to events. So for example, you have anchors, you have a form, you can actually fire VB code from events off of that page. And the way you do that is by connecting tags. You can connect the tags on the HTML to other web items or to custom events. And we're going to see some examples of doing that. Again, think of this like a page. So let's go into another demo. Okay, before I actually show you this demo, I want to show you what the HTML file looks like prior to importing it into this project. So I'm going to bring up Visual InterDev and show you the actual HTML file. Okay, it's a simple menu screen, okay, with 4 hyperlinks on it and a button surrounded in a form. If we look at the source, we're going to see we have a few hyperlinks here with no destination to them. And also, in our form, we don't have any action for the form. So now, when I actually import this HTML file, when I import that into the project, and now I'm going to show you what this file looks like now. Okay, you see, we've actually added destinations for any event that we connect. And those destinations, again, are the ASP file with the parameters on them, WCI and WCE if we're calling a custom event. Now, again, we still have a couple here which have no URL on them. That's because we haven't connected them from the design time surface. So let's go back now. As you see on the right here, we're listing every connectable tag that we can connect VB code to. So how do I go about connecting the actual HTML tag to Visual Basic Code? Well, all I need to do is right-click on the tag itself and select either Connect to Custom Event or Connect to a Web Item. In this case, I'll just connect to a custom event. And as you see, we have target here become hyperlink. Well, I guess you can't see that, but believe me, the target becomes hyperlink 3, which is the name of the actual tag that we brought in here. And now let's look at the HTML again. Now for this third hyperlink, we actually have a URL here again. And as I was mentioning before, this part of the URL, you never need to worry about generating because of the URL for function, given the name of a web item and the event of the web item, you can automatically generate that URL. So, now let's actually step through this code. And we're going to see that we can actually run VB code from HTML tags. So we have this menu of options, choice 1, 2, 3, and 4, and the exit button below. We click on choice 1, and we're going into the custom event that we actually connected this to. And we're executing Visual Basic code. And again, all we do is write out a message. And I'm also going to write out a hyperlink going back to the main menu using my helper function HTML hyperlink. Okay, choice 1, and now I'm going to go back to the main menu, which invokes the respond event. And I'll write that out again using the write template method. The write template method will take any of your HTML, write it out automatically to the browser. Now that choice 1 automatically connected to a custom event. Now, we can also connect to a custom web item or a HTML template web item. Choice 2 is actually connected to a custom web item. So if we click on that, we come into our standard response _ respond event. Now this is a custom web item that we've defined in the design surface for the web class. And again, we're just going to write out a response to the user. Okay, so those are two examples of connecting up actual anchor tags in your HTML to Visual Basic code. Now those aren't the only ones. Any tag that submits an HTTP request can be connected. So I've got a form down here as my exit button. I click on that. That executes the Visual Basic code, just thanking the user for using the application. Okay, as I mentioned before, the events off of template web items are a lot similar to custom web items, except we have one more. We have an event called process tag. Now, HTML templates become really interesting when you want to have just generic forms or generic HTML user interface, and you can actually customize that based on what your application does. And the way we do that is all the UI designer needs to do is place custom XML tags into the HTML itself. What the web class will do in turn is look for these tags, and actually you can inject your own HTML where those tags were. Okay, so when it finds one of these tags, like I mentioned, the process tag event gets fired. And why don't we just actually, instead of talking about it, go through some code again, which is going to show this a lot better. Okay. In this web class, I have a HTML template web item called tags. I want to show you what this file looks like prior to actual tag processing. I'll bring that up in Visual InterDev. Okay, in the actual code, you'll see I have a bunch of tags in here starting with WC and the @ sign. You're going to have WC @ name, WC @ visit number, and WC @ day. These are tags that a user interface designer would put throughout their template web items for tag replacement, custom by the WebClass application. Now notice these are also closed by ending tags as well. And in between, I just have some generic placeholders here: no name retrieved, no number retrieved, and no day retrieved. So let's go into the actual code now. When we start up, we're going to set a application variable using the application ASP object. And all we're going to do is collect the number of times this application's been hit, since we're going to display that data later on in the tag processing. So let's start stepping through this. We hit the start code, and then we set our next item equal to the tag's HTML template web item. That in turn, again, automatically invokes the respond event. And here all we do is call the write template method. But wait, we haven't just wrote the template out this time. That is because we found markup tags this time to actually look for. So what we're doing here is we get a tag name and tag content. What we want to do is look for a tag name, write code for a specific tag name in the web class. And we can actually replace the tag contents that are currently there. Now the tag contents come in default as to what was in between the two tags in my HTML. So for the WC @ name, for example, had no name retrieved as the tag contents originally. Well, we're going to change that now. We're going to change that to an actual name. So we're going to change that to John. Now we're going to come back again. We found another tag, the visit number tag. We're going to change the tag contents there to the application's object's hit number. And we found one more tag, WC @ day. And we're going to change those tag contents as well. Once we do that, now we get a custom view catered towards this web class application. Now, there's a couple different options that you can do with tag processing. And you may be wondering, okay, well, if I have all these tags throughout my template, how am I going to find them? Isn't it going to take a long time to actually parse through the file and find them? Well, we do have a specific way in which we look for those tags. Remember, all of our tags start with WC @. This can be actually changed. We have a property off of the actual HTML template web item called tag prefix. So you can change this to anything you want. So for example, your UI designer designed your HTML file for use with the application, and instead of using WC @ used IIX. You can change the tag prefix to look for all tags with IIX, and then you'll automatically come into the process tag event for all tags with IIX in the web class. There's also another option that we have, rescan replacements. Now, what rescan replacements does, envision that you go in, you find a tag, you make a change, you add new tag contents, but in those new tag contents, you add new tags to look for. Now, normally, rescan replacements is turned to false. So meaning, if you were to put those tags in there, we're not going to find them. We're just going to keep going and find the rest of the tags in the page. If you turn rescan replacements onto true, we're going to rescan the replacement for tag contents until there's no more new tags. So I'm going to make this true, and I'm also going to go uncomment some code I had here out. Basically, what I'll be doing here is now, instead of just saying tag contents equals John, I'm going to say tag contents equals John and this new set of tags to look for. And I also put in a new case statement for that tag, WC at name 2. So let's actually step through the code now. Okay, again, we go through the start and set the next item equal to the tag's HTML template web item. We write the template out, and now that, again, invokes the process tag event. We find the WC at name, and we set its tag contents. And now since rescan replacement is true, what we're going to do is we're going to find WC at name 2. And we're going to set the tag contents of that equal to do. And as usual, we're going to find the other tags as well. So now, as you see, we have greetings John Doe. Okay, we actually did 2 tag replacements there. So imagine if you were dynamically creating a table from a database that you didn't know how many fields were on. You could keep adding these tags until you had no more fields. This is a really powerful concept. Okay, so what we saw here is the ability to create generic HTML forms. And for example, the example I like to give to customers is, for example, a logon form. This is what I did with the airline application. This was a generic logon form with a couple text boxes and a generic title and some generic pictures on it. I had markup tags around the title and the pictures. And what I did in the airline application that we saw earlier was replace that title and replace those pictures and customize it. So that HTML template could be used in any other application that I choose to have logon functionality in as well. Any modifications that need to be done can be done through actually processing tags and changing the HTML in the file. Okay, here again I'm just showing you the syntax for the tags. Okay, that pretty much does it for the actual WebClass programming model itself. Now I want to go into ASP objects, since this is WebClasses or Visual Basic's way of getting at the ASP objects, not mandating you to write script. So the objects that I'm going to cover are the request object, the response object, the session object, the application, the server object, the object context object, and the browser type object. The request object. The request object is just basically information passed from the browser to the server. A few interesting properties and methods here are client certificate, query string, form, and cookies. You can actually request the values of a cookie off of a client. You can get security information for the client certificate. You can actually look at the URL, the parameters on the URL using query string. Or you can check actual values and elements on your form. Or like you've seen I did before, check the text within text boxes, or actually check and see what button has been clicked on a form. The response object. The response object basically sends information to the browser. We were using this quite extensively in all these examples here, response.write, for example. Now, you may remember that in the ASP file I showed earlier, we set response.buffer equal to true. Well, this is actually the reverse of what is normal in ASP programming. It's usually set default to false. We set that to true just because we want to optimize for a web class, we want all the output coming at once. Cookies allow you to actually write cookies out to the client machine. The clear end and flush methods. This is another reason we set the buffer property to true to begin with. The buffer property needs to be true for these to work. Clear will just clear out any buffered output that you've sent already to the browser, but it hasn't got to the browser yet because it's buffered. Flush will flush all that out and send it to the browser. And the end is kind of synonymous to an exit sub in Visual Basic, so that's really not needed. Redirect. One note on redirect. Redirect will make a round trip between the client and the server. So if you need to move between different web items, again, use the next item property. Now, there are times where you'll need the redirect method, and that's when you need to navigate to pages outside of the web class. So it's still important nonetheless. The session object. The session object is one user's server-side state over multiple HTTP requests. For this to work, though, the browser must have cookie support. Cool things to know, it works with variants and objects. However, objects stored can't have any threading model, but for ultimate scalability, you should have the threading model of the objects you store here marked as both. And the reason why is if you start putting apartment-threaded or single-threaded objects in here, you're going to limit yourself to that thread. If other clients are currently accessing the web class on that thread, you have to wait for them to finish, therefore really impacting scalability. And to see here, I have a couple examples of actually setting information in the session object. I'm setting a form element called ID. I'm setting that actually setting a variable in the session called ID equal to that. I'm also creating a ADO connection and actually storing that in the session object as well. Probably not something you want to do, but for demo purposes, you can do that. Actually, I'm going to take questions after the talk, so go on here. The application object. This is all users' state for one internet application. So for example, you saw in one of my demos, I was getting a hit count on how many times this application was accessed. Okay, if I was to run this from here and then have another computer running it from Washington, for example, the hit number would increase for each person using the application. Now, objects stored here must have, you don't have a choice here. You must have your object stored, a threading model as both if you're going to put objects in here. That is a requirement in IIS. They enforce that. The lock and unlock methods should be used when writing data or accessing data from the application object, as more than one application could try to overwrite data at the same time. And one caveat here is that when you're running inside the IDE, Visual Basic will actually let you store components that are marked as single-threaded or apartment-threaded in these objects. And when you go to compile and run, you'll get errors when you try to do this. So just, this is the consequence of running in our debugger right now out of process. In future releases, we're going to work on running in the exact same context as IIS. So something to remember. The server object. The server object is basically a bunch of useful utility functions for encoding. For example, HTML encode, URL encode. You give a specific string, and it'll give you the HTML encoding that you need to put that into a web page. URL encode is pretty much the same thing, except applying rules for URLs. Create object. Now, for those of you that are experienced VB programmers are going to wonder what's the difference between server.createObject and VBA.createObject. Well, the difference here is the server create object is the object you're creating implements the on-start page and on-end page events. Those events will be invoked. They won't if you're using the VBA create object method, so something to remember there. And the map path method, given a path, given a virtual root, will give you the physical path on the server. The object context object. This was introduced in IIS 4.0. This was introduced to give transaction functionality to web pages. And how you would go about doing that is putting an transaction directive in the actual HTML page itself. If you go and use this with the web class, you're going to have, well, you won't have problems, but you're probably not going to get what you expect either. Because this is going to place the entire web class in a transaction, which you don't want to do. You want to have your transactions as short and compact as possible. And what I'm going to recommend is actually, since you have the ability to call COM objects from your web class, package all your business rules in those COM objects. Place those in MTS. That way you have control over when the transaction starts. You have control over when the transaction ends as well. The browser type object. This basically allows you to query the browser that's making an HTTP request to the server, gather information about that browser, brand, version info, cookie support, frame support, scripting, etc. This will allow you to actually modify your web class application for the actual client that's calling in. Now on to state management. I want to briefly go over what the state models are. First, we have a state list model. In the state list model for web classes, you create and destroy the web class for each HTTP request. This is the default. Why this is the default? This is the default because this will enhance your scalability. This will provide the greatest scalability of both methods. The state full model, on the other hand, the web class gets created on the first request and doesn't get destroyed until the release instance method of the web class is called. And we're actually storing the web class itself in the session object. So again, going back to our talk on threading, the session object, you can store apartment threaded objects in there. However, again, if you go ahead and do that, you're limiting yourself to a specific thread at that point. So whenever possible, try not to use the state full model, and I'll actually show you how to set the state models in the web class here right now. Okay. On your web class, you have a property called state management. And there's two values that you can set this property to. One is no state, and the other is retain instance. And this is basically, goes back to what the stateless model and state full model were on the previous slide I was showing you. Now, again, we default to WC no state, which is the stateless model. So any public variables or any information you store in the web class itself will be lost coming back between HTTP requests. However, there are other ways to keep that state, so don't worry about it if you want to make a stateless object. So to actually set this, we just click on the state, the web class itself, and over here is the property. I know it's probably hard for you all to see, so we're just going to set this to WC no state. And now I want to show you the actual life cycle that we're going to be going through here, what events get called and when. So we come in, and we come into the initialize event. And the reason I have a message box here is, and this is something important for you to remember too, is in the initialize and the terminate event of the web class, you don't have access to the ASP objects. They're not initialized at the initialize, and they're not actually around at the initialize point, and they're destroyed at the time you get to the terminate point. So right here, all I'm doing is putting up a message box saying we got to the initialize routine. And then all I'm doing is I'm writing a response out for each event that actually gets called. Okay, so with the state list model, we get a begin request, we get the start event, we get the end request, we also have the initialize before, and we also get the terminate. Now, if I was to go in and actually change this, actually change the state management to retain instance, we'll see something different this time. Okay, we're going to get the initialize event again. And we're going to go into the begin request. Then we're going to actually hit the event that we're looking for, the web item that we're looking for. and then we're going to hit the end request. But notice this time, we do not hit the terminate event. Okay, this is because we're keeping the web class around at this point. Now, if I was to make one change in the code here, and actually do a refresh on this page, notice when we come back into it the second time, the initialize event now is not called. That's because we've already created the web class. No need to go initialize it again because we kept it around. So again, we write our response for the begin request, the start, and the end request. Now notice here I uncommented out a piece of code called release instance. What this is going to do is it's going to instruct the web class that, okay, you're done with me, I can unload myself now. So once that happens, I get the terminate event. And we actually terminate. Okay, and this is just stepping through what we're just seeing in the code here. In the stateless event lifecycle, we will always get these events in this order: initialize, begin request, the start or the web item event that we're calling into, the end request event, and terminate. And for the stateful lifecycle, we'll get the initialize event when the instance is created, and then after one or more steps of calling into the web class, we're going to get begin request, start, or the web item we're calling into, and the end request event. And then when we call into release instance, we'll actually hit the terminate event. Okay, so if we make these stateless web class applications, which is basically what I'm telling you to do here, how do we actually store the state? Well, one is, again, you can make the web class stateful and just store public properties. Again, that's less scalable. Two, you can use the session object. You can use that. You don't have to have the web class in stateful mode. Thus, your scalability will be increased dramatically. Again, just avoid apartment-threaded objects when using the session object. You can also store state in the application object. This can be used, again, in stateless mode. And again, you can only use objects here, which are marked as both. I recommend if you're going to use either of these two objects, just store a string or some kind of key value in that actually that identifies records in a database where you store the rest of your state. There's a unique property that we've defined called URL data. URL data actually is the third parameter on our URL when we make a call into the web class. We have WCI, WCE, and WCU. WCU is just additional data you want to send along from the client to the server. This provides you the ability just to send a simple amount of data along. There are some limitations. You're only limited to the length of a URL. A database. Like I was saying before, put the key in the session or the URL data or the application object. I mean, databases are perfect for storing state, so try to utilize that as much as possible. This also provides long-term persistence, which other methods do not. The URL data doesn't, session object doesn't, the application doesn't. You can also use cookies. The pro to doing this is you have response and request objects which wrap that functionality to read and write cookies. However, the bad part about this is your user may have cookies turned off, so you're going to have to take that into account. Then the last way to actually manage state is use hidden fields. However, that's going to require an HTML web item with a form on it. Advanced topics. Okay. Performance and scalability. As I was saying before, VB6 is still apartment threaded. Okay? That's something we'll work on, but for the time being, we have to deal with this. Storing an object in the application object is not permitted. Storing an object in session object is going to kill your scalability, so don't do it. If you're going to store objects, try to make sure they're marked as both. And again, this just basically limits IIS's ability to do load balancing. And IIS has pretty good ways of doing load balancing as long as you play by the rules. So again, just refrain from putting VB objects into the session or application. In Visual Basic 6.0, we did make some server-side optimizations to the product. One, we put in a feature called retain in memory. Basically, what retain in memory is, we're seeing the scenario where we're coming in and a user was using a server component. They get done with the component, it starts tearing itself down. In the meantime, another user comes in and tries to use that component. However, there's a lock on the component at this point, so they have to wait. Well, what retain in memory does is it doesn't go into that destroy code anymore so quickly. So what will happen is, instead of having that lock on the DLL code or code running on the server, you can actually come in now and keep executing and not having to worry about waiting for the component to destroy itself. In initial tests, we've seen processor utilization jump from 40% on a quad processor to 99%. This was very, very needed and very, very useful. When using web classes, always use unattended execution. Obviously, this is going to run in the IIS service, so you don't want message boxes or anything like that popping up. And here I'm just showing you quickly the options you need to set when building a web class. Obviously, set it department threaded, unattended execution turned on, and retained in memory turned on. Transactions and scalability. As I was mentioning before, put transactions on your business objects. Call those business objects from other, put those business objects in MTS and have those reside in other COM components other than the web class. That way you have control over when a transaction will start and end. Plus you'll get scalability that MTS provides for you. Okay, so briefly a summary. A web class is a COM component hosted by IIS. And it's a container for resources called web items. Web class responds to HTTP requests and can generate content on the fly as well. The mandatory call to action, use VB6, create web class applications. Let your UI designers do what they do best. Let them create the HTML pages that constitute the user interface of your application. And as programmers, you can actually write the code behind that. And also build business components in ActiveX DLLs, run them in MTS, and achieve greater scalability and transaction capability if you wish to. And additional information, Visual Studio Docs, and NSDN, and programming active server pages. Okay, at this time, I'll be taking questions. If you want, just step up to the mic and ask any questions you may have. Thank you all for coming. No, not at all. It's just a reference to the HTML. Nothing more. Where you want to use web classes are where you have a lot of data-intensive code, and you can actually call directly in using compiled code, and that will grab your data quicker than going through a script using variants, because we'll be using native types in the web